All right, we're on to the last part of the notes. And once again, I'm going to be giving you a formula. So there's a general formula that you can use to find the nth term of should not say arithmetic sequence, because of course we're on to geometric. Cross that off. Sorry. So if we are working on geometric sequences, the IB formula booklet is going to give you this formula. It is U sub n, it's just the value of the nth term, is equal to U sub 1, that is again the first term, times your common ratio to the n minus 1 power. And we'll explain why that formula is the case in just a second. So once again, change that arithmetic to geometric. That's a copy and paste mistake from the last notes. All right, so we have this geometric sequence, 1, 4, 16, 64, and so on, and so on, and so on. And we want to find the ninth term in the sequence. Now, of course, you could just sit there and multiply by 4 each time, but what fun is that? We want to use the formula for it. So we are going to be starting with U sub 9, because we're trying to find the ninth term, is equal to U sub 1, and the first term is 1, and it's multiplying by the common ratio, which is 4. You'll notice it's multiplying by 4 every single time, to the n minus 1 power. Important to have the n minus 1 power up there. So order of operations says, well, treat that 9 minus 1 kind of like a parentheses. So we get 1 times 4 to the 8th, and then we have to do the exponent. So we are going to be taking 4 and raising it to the 8th power. Let me get a calculator out. We have 4 to the 8th power, and that's going to give you 65,536. And of course, if you take 1 times that number, we just get the same number. So it's 65,536 is the ninth term in that sequence. So once again, I want to show you why this formula works out the way it does. So you have the first term is a 1, the second term is a 4, third term, fourth term, fifth, sixth, seventh, eighth, and ninth. So we're starting here at this 1, that's our first term. We're trying to get to our ninth term over here, and we're multiplying by 4 once, twice, 3 times, 4 times, 5 times, 6, 7, and we had to multiply it 8 times in order to get to the ninth term. And that's why you see here, we take our starting point, which was a 1 in this case, and we multiply by our common ratio 8 times in order to get to the ninth term. So hopefully you can see why that formula has that n minus 1 component up there. So that's just a quick little tutorial on why that formula works out the way it does. So now let's go on to one more example. And we once again have a geometric sequence. And it's 5, 15, 45, so on, so on, so on. It's multiplying by 3 every single time. And I want to find the least, that should say least, so many typos here. I want to find the least value of n such that the nth term is greater than 50,000. So basically, what's the first term where it becomes greater than 50,000? So let's start with our formula. We have U sub n is equal to U sub 1, that's going to be a 5, times your common ratio, which is 3, to the n minus 1 power. But I do know that the value should at least exceed 50,000. So let's replace U sub n with 50,000. And the term has to be greater than that. So I'm going to put a little inequality symbol. So this value, the term's value, has to exceed, that's why it's greater than 50,000. And now we're going to go ahead and solve for n. So the first thing, we're going to get rid of that 5. Divide by 5 on both sides. And if you divide by 5 on both sides, we end up with 10,000. 10,000. 10,000. 10,000. 10,000. 10,000. 10,000. 10,000. 10,000. 10,000. 10,000. 10,000. 10,000. 10,000. 10,000. 10,000. 10,000. 10,000. 10,000. 10,000. 10,000. 10,000. 10,000. 10,000. 10,000. 10,000. 10,000. 10,000. 10,000. 10,000. 10,000. 10,000. 10,000. 10,000. 10,000. 10,000. 10,000. 10,000. 10,000. 10,000. 10,000. 10,000. 10,000. 10,000. 10,000. 10,000. 10,000. 10,000. 10,000. 10,000. 10,000. 10,000. 10,000. 10,000. 10,000. 10,000. 10,000. 10,000. 10,000. 10,000. 10,000. 10,000. 10,000. 10,000. Now, if there's a place where you might have forgotten something from last year, it's probably right here, and it has to do with logarithms. So whenever you have a variable up as an exponent, in this case it has a base of 3, to solve it you're going to use a logarithm. So in this case, the base is 3, and to solve it, I'm going to take the log with a base of 3. So the way we write this is log base 3 of 10,000, put our inequality symbol, and then log base 3 of 3 to the n minus 1 power. And the reason I do this is because, hopefully you remember the power rule of logs. You can take this exponent and throw it in front, and then the log base 3 of 3 is just equal to 1. So by doing this, it essentially just cancels out the log base 3 of 3, and you're just left with n minus 1. So we get log base 3 of 10,000, and then n minus 1 over here. So we canceled out those logs. Now you might also be wondering how to calculate this. Essentially what this means is 3 to the what power is equal to 10,000. That's what a log is telling you. It's what an exponent would have to be on this 3 in order to make that number 10,000. So we're going to go to Desmos, and you will see some different functions in here. And you can see there's one that says log base A. So this one allows you to type in any base you want. So we want log base 3 of 10,000. And then it just tells you 8.38. So you could do that. Let's say you didn't have Desmos and you didn't know how to do that. That's fine. On any scientific calculator, they're going to have the normal log button. So in this case, we could do log of 10,000, and then you could divide it by the log of 3. That's something called the change of base formula. We just changed it into a log with a base of 10, and you still get the same answer. So if you don't have access to Desmos, I'm not sure why you wouldn't, but if you just have one of those scientific calculators, it gives you 8.38. We'll round it there. Let's go back to our notes. So this becomes 8.38 is less than n minus 1. And then we can add 1 to both sides. That becomes 9.38. And if you read it from the variable, this means that n, the term number, has to be greater than 9.38. We're not rounding it down because we know that n has to be greater. So the first term that's bigger than that would be the 10th term. So n is going to be term number 10. One thing that I would do is I would always double check my work at the very end. So I would find what is the value of the 10th term, and we can go u sub 10 would equal our first term, which is 5, times our common ratio, which is 3, to the 10 minus 1 power. And then we could have 5 times 3 to the 9th power, and let's use Desmos to figure out what that is. We have 5 times 3 to the 9th power, and that gives you 98,415. That would be the 10th term. If I want the term before it, we can just hit delete there and change that to an 8. The term before it would have only been 32,805. So we have found the first term, it's a 10th term, where the value becomes greater than 50,000. And that was just a little reminder about how logs work. So there's a couple to do on your own, and then there's an assignment on both arithmetic and geometric sequences for this week. Next week, we can look forward to series. So finish that assignment and have a good rest of the week.